at it for many years.
We're all in agreement, comma.
We actually we're even looking at doing shipping containers on a project in Sylmar on city of LA owned land, and ultimately we decided not to pursue that venture because it didn't make sense at the time with the hillside and there's some other challenges. So we've continued to look for modular opportunities. We've continued to research it as an organization. And currently we're actually in the early stages of doing our first modular development. It's going to be hopefully 50 units, 50 unit senior development in, here, I'll share my screen so you can see it. Let's see here. I'm talking. All right. So this particular development will be 50 units. It will be for seniors. This particular site, and Lana will talk about a lot of this, is fairly conducive to modular. It's flat. It has a lot of space to store and stage the modules. It's maybe a little on the small side from a scalability perspective with 50 units, but still pretty sizable. And you'll notice that all the units are basically the same or similar floor plan. Standardization is a key. So this site, the interesting thing that you will note that if you look at the elevations is, it looks like every other beautiful affordable housing development that we do, right? And that's because modular doesn't change what the project looks like. Modular is just the base that you use to build the units, but you can put the skin on, as they say, or have it look like anything you want. So I figured it was important to show you that context that there's, I think, a lot of misconceptions about what modular housing is and isn't, but it is something that can look like, or will look like any other development. I will also say before I turn it over to Lana, there's a few reasons that Many Mansions is looking at modular at this point. One of the biggest reasons is actually mission alignment. Many Mansions works a lot with permanent supportive housing for people that are homeless and disabled or living in living conditions that aren't really suitable or conducive to thriving. And by building housing faster, that helps fulfill our mission of getting people off the streets more quickly, right? And so if we can shave time off the construction schedule, which again, we'll talk about this more, that's a big deal. If you're living on the streets every week, every day, every hour is a big deal. So if we can shave months off that schedule, that means a lot. And also for us, it's a way to actually save staff time and resources. It takes a lot of time to develop these plans, to look at these sites. If you can standardize that process, it actually is much more efficient and reduces time. Another thing that it also does is actually makes us better neighbors, right? When you're building construction, it can be loud, it can be noisy, it can, there's a lot of construction traffic, in the neighborhood. So if you can put some of that off-site, you reduce the number of construction vehicle trips, you reduce a lot of that hammering and work that you see on the active construction site, because really the most noisy part of the construction process and the part that has the most construction traffic is building the units themselves, right? So there's a lot of good reasons to do modular. There's a lot of things that we're still learning about it as we go. And part of that learning process has actually been working with Prefab Logic and Lana and her team, who are experts in the modular space and are really helping our team work through this process and make sure that we're successful. So I'll turn it over to Lana, and you guys enjoy the presentation.
Just before we do that, this is Ann Sobel, the Vice President with Resource Development. I just wanted to encourage you to, if you have any questions as we're going through, to put them in the chat for us. And Alex and Lana will work to answer those at the end of the program. And also, if you don't mind just putting your name in the chat box, as Alex said, that would be great so that we can know who's here. Zoom does not provide us a list of all of the attendees. So if you wouldn't mind doing that, we'd be grateful. Thanks. Lana, your turn.
Okay, well, Alex already covered it all, so I'm done. I'm just kidding. Here we go. All right, can everybody see my screen? Am I sharing?
Yep.
Okay, good. We use Teams, so switching over to Zoom, sometimes I'm a technology goofball. So, okay, my name is Lana Cook. I'm with Prefab Logic. I'm the business development manager here. We are an Idaho-based modular pre-construction consulting firm. I am based here in Southern California. I am working with many mansions and a number of other folks on a modular project and modular projects. And I'm just going to give you a little talk today about, what it is, what we're doing, and sort of the progress of modular going forward. So if you have questions, you can post them in the chat. If it's frantic, just butt in. You guys are not all on automatic mute. So if you're driving, maybe you can mute and then I'll answer what I can, and we'll do Q&A at the end. So let me see why my pages aren't changing. Sorry, we're having a little technological. Are you guys seeing anything?
Yeah, we see the initial screen.
Yep, it is not changing. That's so strange. Bear with me for 1 sec, folks. Sorry. There we go. Okay. Hey, Alex, are you still screen sharing? For some reason, it won't release it to me.
Thought that might be the issue, and I checked, and it does not look like I am screen sharing. But let me check.
I have a red light. How's that?
Oh, that's better. Or at least I can see.
Yay. Okay. Are we good? First screen, are we good?
First screen, yes.
Okay, good. All right, so a little bit about modular. Everybody always likes to say that, oh, it's so new, I don't want to be the first person to try it. And let's kind of go back in history. We'll make this really quick. Modular started in, as far back as I can find, 1908. Sears, Roebuck started doing modular kit homes back in 1908. In Montreal, the World's Fair built a containerized housing project that still people are living in today. That started in 1968. Typical mobile homes, I pulled a picture from 2000. Those have been common for the last 40 years. Manufactured housing, which is a little bit different than the old mobile home platform. There's a picture from current 2020. And DSA classrooms, which we all see on public school sites around the state. That's current. And if you look way down at the bottom, that is a project that most of our team worked on back in 2002. Those are townhomes in San Jose that today sell for upwards of $1 million. So modular in the world that I live in today has been around for 20 years. So it's not new anymore, but the process is evolving and we're happy to be part of that process. And so for what we do today, we've developed projects with clients that range from hotels to apartments to workforce housing, townhomes, slab on grade buildings, over podium, student housing, you name it, we've covered it. It's wood frame construction, type 5 and type 3. And really that means I can go single story to 5 stories over podium with this sort of volumetric mass produced product. So we're not talking about single family homes. We're not talking about manufactured housing for single family. We're not talking about panelized or kit products or SIP panels. This is truly a full 6-sided box, mass-produced type housing product. So in the terms of modular in my world, and we're all going to stay in my world today, this is a factory produced product that is under the jurisdiction of the state of California. So any state that the product is going into, the state is the jurisdiction. So the state does plan check and approval, and they do factory inspection and approval of the product as it's being built. Again, wood frame, and this is volumetric production. So what that means is kind of envision in the back of your mind, like the Coca-Cola plant, moving the Coke bottles through the production facility. All the Coke bottles are the same, and they're produced on various stations along the way through the production line. That's how this product is built. This is not, we call it lots. There's a lot of slang terms for placing a module in the center of your plant and then bringing your workforce to that location, and then all of the workforce doing different trades. That's not this process. This is moving it station to station. And each station does one piece of the puzzle, so to speak. So volumetric production, wood construction, and under the jurisdiction of the state. So modular really makes sense when the cost of labor in the market, the local market, is high, and you want to make sure that there's a delta between the factory labor rate and the field market rate. And sometimes those are on par, but it really, if you're looking for a cost differential, the biggest swing is the difference of the cost of labor in the plant versus labor in the field. There's also markets where the availability of skilled labor is increasingly more challenging. And I can tell you that Salt Lake City is one of those markets where the boom of housing has surpassed the availability of labor in the market. So it almost doesn't matter anymore if what the project costs if they can't find the people to actually build it. You know, people have in their mind what things cost until there's no way to get it done. So modular really makes sense where the availability of trades, and we all know that after the recession, so many people got out of the trades, and we're now dealing, especially in Southern California, with a smaller pool of subcontractors. So when those subcontractors are all busy, modular then moves some of that work away from the subcontractor and into the factory so that fewer subs are needed on site. Modular also makes sense when project timelines are short. You know, you have funding deadlines, you need to get vertical quicker. Alex mentioned, you know, getting housing in the market sooner, quicker. Modular is a huge part of that. The typical modular project shaves off about 1/3 of a modular schedule, and that's in projects ranging from 50 to 300 units. We can usually shave about 1/3 off the overall construction schedule. In addition to that, we can shave off at least 1/4, if not 1/3, of the actual pre-con schedule, which then is, you know, if you can shave off a year of your whole construction project, it's a win all the way around. And then when sites are limited, difficult, inner city, urban, very little laydown area, very little parking, modular again makes sense because about 70% of the project is then coming out completed. So you need fewer people to be able to finish out the project. Again, less noise, all that kind of stuff. But really, if the project, we love big, wide, flat sites. That doesn't happen very often, except Many Mansions has a great site for that. But when we are limited in urban environments, modular makes a lot of sense. Mountain conditions. And then we jump to weather conditions. We do a lot of work in Tahoe, Mammoth, Vail, Aspen, you know, places where not only is the availability of skilled trades minimal, the cost of getting workforce to those markets is expensive. And then everything has to be done kind of in that spring and summer time frame. So modular is in Montana, lots of things happening in Montana where weather plays a big part in the equation of construction. So modular is really viable in the multifamily sector when the product that the factories are producing is repetitive. The more repetitive, the quicker a factory can ramp up and get good at what they're building. and really become efficient, move the product through faster. Everybody in the plant then gets better at what they're doing on each particular module. And the more repetitive the units are, the better, not just for cost, but the better efficiency and the quicker you can produce. We always stem everything we do back to design. And so when the design is modular friendly, and really it's, right-hand side of this slide is thinking within the module that we move through production and then transport down the road, making sure that the architectural side of the design is modular friendly. And then that design, both from the architect side and the unit layout side, all the way through to the site and how we're using available space, follows the rules of modular. And there are very definitive rules to follow. And if you follow them, you can have a great modular project. If you start bending those rules, and let's say thinking outside the box, then modular becomes more difficult to build, becomes more challenging for the factory to get good at it. It becomes less cost effective, and it adds more work to the contractor in the field. And as a result, it will just make the project schedule longer and slow things down. So we really want to stick to the rules, and really modular is planning in advance. There's no time to fix things on the fly or make changes on the fly. Because this is a state approved product, the factory can't build anything until they have state approval. Well, there's a lot of things that have to happen before we can go get state approval. So the project has to be fully designed, and the whole concept of design build sort of goes out the window on modular. So we're planning in advance, we're preloading the schedule with a whole lot more of the project design and decision-making process, so that we can get to that state approval and we can get to the factory, and then we can get it to the site in a sequence that really shaves off the time. Again, getting housing to the market quicker. And the last really important part of a modular project being viable is picking your team. And I know that I said I've been doing this for about 30 years, but really in the housing side, I'm about 6 years into high density housing with modular, and commercial before that. And we have worked as a pre-construction consulting team. And even before that, when we were all at a manufacturing and manufacturer together, we really worked hard to pick not so much architects, because we're open to training anybody, but structural engineers, mechanical engineers, plumbing designers, all of the parts and pieces that make up a project team, general contractors, subcontractors, really pulling together people that are interested in learning modular, looking for better ways to do it, and helping us innovate processes. So it's picking a team and picking a flexible and very open to the idea of change team. So modular pros and cons. I don't like to sugarcoat every, glorious aspect of modular. I want to lay everything out there crystal clear, but let's start with the cons. We're going to start with the right-hand side of the page. I have clients that say they want to build the same thing over and over, or, do I have a plan that somebody else has built and they could just build that exact same building? Unfortunately, land is unique, so no two projects ever end up being the same. I think that pertains more to unit plans that you can reuse, but really building plans, the concept is in everyone's mind, but it doesn't really come to fruition. So because land is different, jurisdictions are different. Northern California is different than Southern California. Tahoe is different than Newport Beach. And because of that, every project being different, it makes it challenging for modular when you're trying to get production through a factory. The other thing is we're building 6-sided boxes. So what you wouldn't be doing in the field, we're building a floor and a roof and walls all the way around in every rectangular box going through production. We're using a little more material than you would be if you were building conventionally. So we have to plan how that all comes together in a manufacturing line differently than you would if you were building up one story at a time in the field. Modular product is not, I say volumetric, but is not mass produced. It's not like the old mobile home days where a factory could pump out, hundreds and hundreds of the exact same thing. This isn't RVs. This isn't car production. This is something that we call in our side of the world a snowflake. Every project is a snowflake and no two seem to be alike. So we're having to change on the fly and making sure that each factory understands every piece of the puzzle so that it gets built correctly. And there are no pre-approved plans from a HUD perspective, like there used to be in manufactured housing. And I think today there still are some HUD approved plans, although we're working towards something like that. That does not exist today. So every project goes into the state of California for approval, just like you would for a regular building permit. We have to transport our product down the road. You don't transport a conventional project. We have to crane install it. You know, so there's a few more steps along the way that are just different than you would be doing with traditional construction. Inefficient layouts, you know, very creative architectural plans don't always fit within our rectangular box that's going through production. So there's some give and take. And small projects, even though clients love to say, but we just have a small project. From a factory perspective, a small project takes just as much time in pre-construction and in ramping up their workforce and production as a large project. So if they're only going to get 3 days of production out of a small project, most factories don't find that appealing whatsoever. So they really want to see, if I'm going to put all this time into getting ready to build this product, that I have a few weeks of production out of it. The average factory builds somewhere between 2 and 6 modules per day. That means, you know, 100 unit building could be out of a factory in 3 weeks. So if you scale that back to a 4 or 6 unit project, that's a matter of hours. It's just not enough work for a factory to get excited about. Now for the good stuff. So modular is faster to market. We're doing things from a construction standpoint where the factory is producing the modules in the factory at the same time the contractor is getting the site ready. So just that overlap time right there can cut out a quarter of the vertical construction time that it would normally take if you were building your foundation and then your first floor and then your second floor going up from there. This is overlapping and really vertical construction of cranes setting the modular boxes into place happens in days, not months. Cranes are expensive, so we want to get in and out. And if the crane is setting, you know, 6 to 12 modules per day, it typically takes a couple weeks. And a project, a modular project is vertical. So faster to market. There is a labor savings. I mean, the factory cost of labor is 9 times out of 10 lower than the field cost of labor. And so if we're talking about Southern California, there's a significant delta. If we're talking Northern California, there is even a greater delta in the difference between factory labor rate and field labor rate. So if that delta exists, then we can probably find that there's cost savings to be had. Modular is also very price certain. So because we're designing and detailing every bit of the project so much earlier in the pre-construction schedule, decisions are made, changes aren't made. And as a result, the product cost has it doesn't just have the inability to move. You have to make significant changes, and those changes become harder and harder in a modular project to make late. So people just don't make them. And we really encourage that we don't make them. And that keeps pricing more certain. Plus the factory buys 100% of their materials that they're using within their product all at once. So they buy that product out about 90 days prior to going into production. So 100% of their materials are purchased. They're on site. Whereas if you're building in the field, you're getting load after load of materials. And if we have things like that are happening today with lumber, where the price changes every day, then as those loads come in, the pricing scale and it tends to change pretty rapidly. So we're much more secure in final pricing much earlier in the process with modular. So because in a manufacturing facility, everybody's doing the same job every day. So when I talked about volumetric production and a module running through a factory instead of the people moving around the factory, the person who's framing walls is framing walls every single day. They're really good at what they do. The people who are installing bathroom fixtures are doing the exact same thing every day. They're very good at it. So if you also think about these 6-sided boxes coming together, there's a 6-sided box with a wall on one side up against a 6-sided box with a wall on the same side. You have some distance. And so you get a better sound, you get better STC ratings and sound transmission ratings, easy for me to say, which really makes a nicer product to live in, makes a nicer hotel to stay in. It makes the product quieter. Everything is square and straight and true, and much more so because we're transporting these boxes down the road. Things that aren't square don't transport well. So we learn very early to make sure that things are square and tight. And then a factory is a weather protected environment. All of the factories we work with are heated, air conditioned. They are environments that are conducive to working. They're ergonomically designed. They are people friendly. One of the facilities we work with has robotics and lots of automation. And so they're really protecting the product as they're building. And then Alex mentioned this as well. We're taking so much of the construction process away from the community and putting it out where, you know, land is plentiful, undercover in another facility, and we're keeping the noise, the trash, the parking, the people, the chaos that tends to happen on every project. We're reducing the time frame that happens, and we're taking, if not 50%, probably more like 70% of that chaos and moving it to a facility somewhere else and bringing the product out much more complete than it would be if you were building conventionally. And that is what everybody knows makes neighbors happy. A shorter duration of a construction cycle, less noise, less traffic, you know, less street closures, just a shorter schedule all the way around. So those are our big pros for modular. Modular makes sense when design is modular friendly, and that is designing in a rectangle. And I know it doesn't sound that creative, but if you really think about unit plans, for those of you that manage facilities today or have them within your portfolio, you already know that there's only so many ways you can build a studio. There's only so many ways you can build a 1-bedroom. And if you're really trying to make efficient product, it probably comes close to a rectangle as it is. We're just sticking to those rules of modular. And that is, you know, keeping your elevators turned in the direction that we can then build it in a production facility. Keeping your kitchens and bathrooms and plumbing all within one of those modular boxes so I can finish as much as possible in that apartment in the offsite facility. And then keeping the module size as big as possible so that I can still transport it down the road to get it to the project site and get the most bang for the buck out of the production facility. And I'll come to that on the next slide as well. But one of the ways we can get the most out of the production facility is building the biggest box possible. But as you can see from this drawing, not every big box works in every particular project. So we have some unique ways of making smaller boxes out of larger boxes and trying to find all of the efficiencies of building 2 pieces in one larger piece of the puzzle and then separating in the field. Our slang term for that is saw boxing, but it does allow us to come up with smaller boxes without losing the efficiencies and without increasing our transportation costs. And then grid alignment is key. Again, designing within that rectangular box, making sure plumbing like kitchens and bathrooms never fall within that magic red line you see on the screen. And making sure that, again, we're really focused on how is the factory going to build this? Do we have access where needed to align chases from floor to floor. There's things that have to be thought out much earlier in the process in modular because there's no tearing apart walls. They're all finished so that you can make a connection in the field. Or we missed a pipe and we've got to find a way to get it from one floor to the next. That doesn't happen in modular. We solve those problems early, but a lot of it stems back to design. So if the design is modular friendly, your economics will start to make a whole lot more sense and the project and the product will become much more efficient. And then here's just a few projects in various stages. Across the top row, this is what a modular project looks like when it's going vertical and they're, picking from the crane and putting each piece into place. Yes, the whole Lego theory is really true. And that's the units are finished on the inside. So these apartments, this is an affordable housing project on the left. Apartments are finished with flooring, drywall, tape, texture, paint, cabinets, counters, light fixtures, ceiling fans, appliances, and then the outsides are just about unfinished. The bottom picture is the completed project itself. Balconies are built in. Everything we possibly can build in at the factory, we want to build in at the factory and leave as little to be completed on site as possible. The middle project is a view of apartments in an automated manufacturing facility before the framing pieces have started to be put together. So the robotics have already cut all the pieces. Each one of those stacks of lumber you see are either roofs or floors, and they're tied to specific units, which eventually, when they're all created and are stacked in the field, will look like the building at the bottom of the page in the center. And then the picture on the right is vertical set of all the boxes on a project in San Jose that is, it's finalized as far as the crane set goes. And in roughly 4.5 months, it's 301 units. It'll look like the picture at the bottom. And that project's underway today. And then modular is I think I mentioned is, there's no design build. And I know that every once in a while somebody slips past me and goes, oh, but you can do this. But really in modular, we want to plan in advance and decide and pick colors and specs and get to design lock early so that so many of the other things that happen behind those items can get handled more quickly than they would if we were making changes late in the game. And what that does, if you make all of your decisions early, should you have any cost impacts, the cost impacts will be low for changes in modular made early. So we have a sequence, we call it our sprint model. And we have a sequence that says in sprint 1, if you make changes, the cost of those changes is very minimal. If you wait until later, after we've gone for state approval or after the factory is getting ready to build and you want to make a change, it's almost like starting over and the cost becomes huge. So make your changes early, very little impact in cost, make them late, and there's a significant impact in cost. And then we like to say that we're on the cutting edge of technology and modular. We really have started doing things, that's kind of the premise of our company, doing things different than the way modular production has been for the last 30 years. So we're using things like virtual reality. 6 weeks into a project, we're starting to do unit walkthroughs. I mean, in a conventional project, clients typically haven't even picked their cabinet color by 6 weeks in. Not only have our clients, many mansions included, picked their cabinet colors, they've picked their countertops, their floors, they've designed all their fixtures. Everything in this unit that you see in the graphic on the left is a VR image of what we're doing when we're walking through unit plans with our clients. Those VRs are built around spec, color, material, and all of that stuff has to be picked and designed and locked in 6 to 8 weeks from project kickoff. So really, really early in the process. We also have on all of our plans, so when we do our state submittal plans, we QR code all of our drawings so that if there's an inspector, let's say a CASP inspector is up at a manufacturing plant and he wants to see what this unit's going to look like when it's finished, because it looks very different when it's in the production line. He can scan the QR code, hold his tablet or iPhone up to the wall that he's looking at while he's doing the inspection, and he can actually see how that, say, kitchen section or bathroom counter will look when it's finished. And he can see that the factory is building it the way the plans read. So there's all kinds of technology that's, you can do in conventional as well, but it's part of the process in modular because we have to get so detailed early. So we have the flexibility to add those things that make it easier for both the manufacturer themselves and the inspectors within the process. And then the virtual reality process is, like I said, part of what we do to get client sign off for design and spec lock. And this video goes a little fast, but we do this with every project we go through pre-con on. Every client does this once, if not more, where we've put each unit plan into VR for the entire project team to walk through. So instead of waiting till your project is going vertical and your units are being finished and you decide that you don't like where an outlet is located, or that soffit didn't look like what you were expecting, you can actually see your whole project. Again, this happens maybe 60 days in from project kickoff. So really, really early in the process. Let's say you didn't like how the cabinets didn't come out as far as, a linen cabinet didn't come out as far as your kitchen cabinets. You'll be able to see that early, long before material gets ordered. So making changes, this is the time. We want to encourage that early in the game. And this video will run for a while. So let me see if I can get past that. There we go. So in modular, the old days of building modular was your architect would create a building plan. We would look at it from the factory perspective. We'd go, yeah, I think we can build that. The idea of a factory is to keep your production line full. So you almost don't care what you're building as long as your production line is full and your employees are working. However, if a project becomes profitable, it's a completely different story. And if you're not sure, then factories tend to just add money to the cost of the product. They don't really know. So what we want to do in our world is we build a full integrated model. And that is MEP, so mechanical, electrical, plumbing, fire, low voltage, framing, all the structural connections. And we build in every single detail, and we design to a level that is, in our world, very high, level 500. So we're getting into modeling everything except screws, nails, and fasteners. And then we run our process through a clash detection software so that we can tell if a plumbing pipe conflicts with a floor joist. I have actually been on projects where I've seen people cut through floor joists because you're never quite sure where that pipe needs to fit. We know where everything needs to fit. And some of the stories of modular projects that have kind of fallen off the rails or haven't gone as smoothly as people anticipated, it's because back in the day, factories built their shop drawings and their state approval packages from architectural drawings. And architectural drawings just aren't enough to get into the weeds of how we're going to take apart that 5-story building, build it at single-story level in a production facility that moves every 20 minutes. So it's really taking apart that 5-story building and taking it all the way back to the design stage and doing it from a very, very, very intricate level. And then we've, just to be a little more descriptive, the funny looking picture on the left is a full building that is in production now. Everything that's turned off in this drawing is framing. So what you see in that cluster of colors that looks like chaos is mechanical, electrical, plumbing, fire, and low voltage in a building. So there's a whole lot of stuff happening within a building that we really need to know where everything runs so that when the factory builds it and it then ships to the field, that the contractor can connect it on site with ease, that we know where every pipe and piece goes, that we know where every structural connection goes. It's a very intricate and detailed process that I think the general public thinks you can call up a factory and order a piece of something or order a building and it's just going to come out the way it comes out. There's a whole lot more that goes into it to make it flow seamlessly. And so there's just a zoomed view on the right and an even more zoomed view. All of that chaos at the bottom in that bright colored picture is what happens for connections for one apartment on one side of a corridor in one piece. So let's just call that a studio apartment. That's all the magic that happens in a studio apartment. We know where all the pipes and parts and pieces go so that the client and the general contractor handling that product for the client gets a quality product they can connect easily in the field. And then taking that to the next level, when a client wants to see their project built, these are the stages at which we're reviewing plans and going into detail, both with the state plan check agency and the contractor and the client, to make sure that everybody knows how the building is coming together so that any problems can be solved early before this drawing is done. This whole video is done in our process long before a product goes into production in the field. One of the manufacturers we work with is automated. So every pipe you see, every hole that has to be drilled through every piece of lumber, all of that has to be defined. If you don't tell a robot what to do, it won't do it. It doesn't think on its own. So we have to make sure that we're detailing this early so that then through the layers of software, the machines know how to cut that material and how pipe will fit. You can see there's a whole lot of connections and there's a whole lot of things that happen behind the drywall. And for us, this is really where the magic happens. And in the old days of modular, there's a little bit of a disconnect in that the factory and the state are responsible for what's built offsite. So the state approval agency is inspecting what's built in the manufacturing plant. What's not built in the manufacturing plant are the connection of all the utilities in the corridors, their laundry rooms, and in this case, a boiler room. There's the plumbing and pipes that happen in the utility chases once the product all comes together in the field. So that becomes the jurisdiction of the local community. So you've got your local plan check or your local building inspector out inspecting things that aren't necessarily on one set of plans, because the architect is responsible for the local plan, and we're responsible for the state plan, but the corridors are kind of that gray area. The structure is built one place and the connections are all done in the field in another. So this used to be a gray area where it left the door open for problems. And in our pursuit of trying to make modular easier, make it more understood, make it more price competitive, make it easier for general contractors to then get true and accurate numbers for their subs, and then you have the trickle down effect, and making it faster and easier on site, is we're doing all of the plan sets that normally would not get done. This would just get built to code in the field, and the contractor would end up having to figure out how it all comes together. Instead, we're laying this out early, so every party to the process has an understanding of what goes into a boiler room, what goes into a trash room, what goes into the fitness center or the manager's office, and how everything comes together in the field. And that really was a part of modular that was completely overlooked in previous years. And we've only been doing this about 18 months. So let's just say prior to 18 months ago, this was just left for them to figure out on site. And I think with this done, we're seeing with our clients today that their projects are even going faster. And I'd hate to be optimistic and say, oh, we cut another third off your timeline. I do know that it saves an enormous amount of time, but we haven't run the analytics on it yet. I should know pretty soon. but we're starting to see significant cost efficiencies, a lot more assertiveness from the contractor pool. The general contractors are more understanding of what they're getting with modular and how to price it, and it has a trickle down effect to the clients. And then our clash detection model, again, we're kind of getting into like the cartoon world, but this is really what we do on every project when we're running clash detection to make sure that, you know, what the factory is building will actually function in the field and that everything will tie in seamlessly, and that modular really can be an easier and more effective product to work with in the field. This is all part of the process, and it really has taken using software. And in order to use this kind of software, we really have to develop the project early and with really, really high level of precision. And then in our process, when I spoke about the VR, on the left is a VR rendered picture of a bathroom, and on the right is the actual finished product. So you can see they're relatively close. And so we're really proud of the work we put in early in the process to make sure that the product that's being delivered in the field is what everybody saw early on and what everybody expected. And then taking modular one step further, this is really going to bring it all to the end here. And that is in our years of doing this, we've been banging our heads against the wall, trying to figure out how we could make modular more cost effective, faster, more efficient. And we went back to that whole saying of, can I just build a building that you've built for another client before? But instead of actually building a building, Effective House are pre-engineered and pre-designed plans for studios, 1-bedroom, 2-bedroom, and 3-bedroom units, and a whole bunch of common areas that are kind of like building blocks. You can take the building blocks and you can plug and play. And they're already designed and engineered, and they're already spec'd so that we've contained all the things that are the variables, mechanical being one of them. Are you using a boiler and a chiller? Are you using a P-TEC or a V-TEC? Are you using mini splits? Well, what is your mechanical system? Until we know that, I don't necessarily know where pipes are running or how big a utility chase needs to be. And that in turn affects the overall unit design. So if you have parameters that you need to follow for net rentable square footage, we wouldn't really even know that stuff until a project is completely spec'd and then designed around that. This really takes, using this particular kind of product takes all of that out of the equation. You have very limited choices. It's kind of going back to that whole mobile home thought process, right? Trying to be able to put out product as quickly as possible for the most cost efficient and effective pricing. And so these plans, because we work with an automated manufacturing facility, there's analytics we can use. Now being able to pull the analytics out of the robots and being able to say, well, gosh, if we build a unit that's 30 feet long instead of 29.5, we reduce the cuts of plywood, we reduce the cuts of lumber, we reduce the cuts of sheetrock, and what makes a building more efficient. So all of these designs in Effective House are built around efficiency of use of materials and use of production. And there are people in plants, even with automation. And so this whole product design is around what is most efficient, cost effective, and affordable. And it reduces all of the costs of the subconsultants, myself included, structural engineers, MEP consultants, fire sprinklers, because so much of the work is done in advance. And Many Mansions really has taken a step above and beyond as they've looked forward into their future projects of seeing how they can most efficiently, most effectively, and most affordably create their projects using building blocks such as these that have already been optimized for not just modular, but the whole construction process. And I will open it up to questions, and I'm happy to answer whatever you have.
Doug
Yep.
has a question.
Alana, could you elaborate a little bit on the state inspection process and when that happens and what you can do in order to avoid making that a rate limiting step?
So the state inspection process happens in our world in what we call Sprint 3. So in pre-construction, when we're focused on getting to design and spec lock and creating the VR and all the processes, as soon as we're at design and spec lock, we start creating the state submittal package. The state submittal on this kind of product is done through a third party in California. So we work with a group called NTA and we do plan submittal. So plan check is done by NTA and they'll come back with their comments. We answer those and we typically have state approval roughly a month to 2 months prior to the local jurisdiction issuing the local building permit. So they run consecutively. So the city permit or the county permit and the state permit usually are applied for at the same time, but the state process, with our package and, us understanding the process, we typically get that done in about a 6-week process.
Thank you.
Sure. So should I be reading from the chat here, Ann?
No.
Okay.
Well, yes, we do have a question. Do all projects have laundry only in a common area?
No, lots of.
Probably, I realize it's probably cheaper to do it, but doesn't seem to serve the residents as well.
So we design and build whatever your architect comes up with for schematic design. So if your architect designs washers and dryers in your units, then that's what you get. That's really, we're not limiting the design in the effective house product. For example, there are options of all of the units to have or not have their own laundry. Everything's a snowflake, right? So whatever you design, as long as it fits in the box, we're going to try to build it.
What about the many mansions project, Alex? Will we have individual laundries or laundry rooms?
We pretty much always do laundry rooms, but obviously for senior properties, we create more and have them on each floor. When you do laundry in the units, it adds a significant amount of cost, not only to the development cycle, but the operations, because you're responsible. A lot of our residents can't afford the laundry machines, the washer, the dryer. So then that becomes an ongoing operating expense to replace those. So we try to make sure that we place them throughout the property, that we provide more than sufficient, more than the recommended number of machines per unit, but typically that's not something we do. There's a lot of cost pressure going on from the state, and we have to be a good and efficient steward. So it's always a balance of all those things.
Here's another one. How has the current building supplies shortage impacted modular construction?
The same way it has impacted conventional construction. Lumber prices have gone up, although I think they're down today. We're facing challenges in, shortages and lack of supply or changing vendors, but the factories do buy out their materials much further in advance than a contractor would if they were building conventionally in the field, that they're buying 100% of their materials. So they know much earlier in the project if a different countertop has to be selected. There was a time when certain countertops were very challenging to get. Lumber is still, you can still get it. It's just more expensive. But some of the fluctuations that happen in the market tend to not affect modular as much because the factories buy directly from most sources. So they're not buying through distributors like you would be if you were buying in the field. So there are certain things that they can get, much better pricing on, and then they're buying out the whole job at once. So, but if the market is up on things like lumber, it's going to affect us. And we use more lumber than you would be if you were building conventionally. So we have it's a little bit of a drag for us there.
Alex?
Yeah.
have a question, Anne.
Oh, go ahead.
We often do a major rehabilitation of the buildings after 15, 20, 25 years. Does this affect any type of major rehab later on? Are you limited in how to rehab in terms of flooring, counters, other things, roofing?
No, and I've been told that it's actually easier to rehab because utilities, when you're building conventionally in the field, sometimes people take creative license of where they're going to run certain pipes and things. This is very contained and very accessible because remember, all these building blocks have to be connected on site. So chases are defined to, you know, certain utilities, and all of that is easier to reach from the corridors. But as far as flooring, cabinets, counters, it's the exact same products and materials and methods that you would be using in the field. So you'd modify accordingly. No difference. Outside of the fact that the inside face of wall of one apartment is a greater distance away from the inside face of wall of another apartment. So the noise that one apartment is going to hear will be less if you're remodeling the unit next door because of that distance. They don't actually share a common wall.
Yeah, I was gonna say the same thing. Usually in AC rehab, the biggest issue is you don't know what's behind the wall. And here you know exactly where everything is. And as Lana mentioned, because they're usually actually in between the units in the chase spaces, it's actually easier to get to than typical construction. So the assumption that we're going with is actually that it'll be easier as well.
Well, Alex, would you like to
Yeah, so
sign
just
together right at 1 o'clock?
yeah, we want to be respectful of everyone's time. Thank you so much for being here. Lana, thank you so much. You've been a great partner, and this was a wonderful presentation.
Thank you for having me.
Thank you to Anne and to Ann Sobel and Ann Sturman for hosting today, and thank you all for being here. If you have additional questions, please reach out to Rick, myself, or anyone on the real estate team. Like I said, we're still learning through the process, but it's been a great experience so far with Lana. We're actually going to visit some of the factories here soon, and so we're excited to see that, and we're looking forward to keeping everyone posted on as we move through this modular journey. So thank you and have a good afternoon.
Thank you, everyone.